In this session, we'll try to discuss how to delete the node from the doubly linked list. We'll discuss about three use cases. The first one is delete the first node, this one. And the second one is delete the last node in this list. That means this one. And the last one is delete the third node, data equal to 75, this one. So these three use cases, we need to understand how the code is and what are the steps we need to take. For any use case, first we need to check where the particular node in the doubly linked list. Let us say first node 55 in the beginning only, and then the last node 85 at the end. So we need to start from beginning of the list till end. Then we reach 85th node, and then we need to delete. For the first node, in the beginning only we can delete. And for the third node 75, we need to traverse from beginning and we need to find out where this particular node resides. Once we reach here, we need to delete this. So for the first case 55, the head points to first node 55. Then if you wanted to remove the first node 55, we need to move this head pointer to the next node here, and then this node previous pointer we need to point to null, okay, so that this node will be deleted. And second use case 85, we need to delete the last node, so we need to start traversing from beginning and we need to reach here. Once we reach here, we need to make the previous node next pointer to null, so that this node will be deleted. This next pointer we need to make it as a null, okay. And for the third use case, we need to traverse from beginning and we need to find out where the particular node 75. We need to traverse one by one. Once we reach here, for this node, what is the previous node? This one. For this node, what is the next node? This one. In order to delete this node, we need to place this particular address in the next reference, and we need to place this address in the previous reference here, so that this node will be deleted. So if you see the diagrams, if we delete 55, the remaining nodes 65, 75, 85. And if you see the picture for deletion of the last node, data equal to 85, the diagram is like this. Head at 55 node, second node 65 as usual, third node 75. This particular node next pointer points to null. And if you see the last use case 75, this picture is like this. Head points to first node 55, second node 65. In the second node, as we discussed, the addresses of last node is placed in the next reference. In this node address is placed. This is the original linked list. Okay, now we'll try to understand the code. Delete the node by value. Delete is a function which is having parameter key passed. The key is a value which node we wanted to delete. We'll have to pass in the main linked list code like this. We are calling delete function in the main code, dll.delete, which node you wanted to delete. Okay, so initially we need to take another reference temp points to the head, and we need to traverse from beginning to end to find out which node you wanted to delete based on the use cases. If temp.data equal to key, whenever the key value we have passed, and it checks the data for each and every node. Very first time, if equal to key, that means first node, right? If not equal to key, what happens? If data not equal to key, let us say here we have a instruction temp equal to temp.next. Likewise, it traverses from beginning to end each and every node to find out whether our node data condition requirements. So let us say we have passed the first node value. That means the first node we finds at the beginning only. That means head points to the first node. Then Again, one more condition inside if, one more if is there. Here temp dot previous is none. So that means previous pointer is none. Then self head equal to temp dot next. That means head pointer moves to the next node because we wanted to delete the first node. Once we move there, if self dot head, we need to make the next node previous pointer to none. Then only the first node will be deleted. For that reason, this is the statement self dot head dot prev equal to none. This is for the first use case. And another use case, we wanted to delete the node at the end. That means node is tail. For that, we have else if condition. Else if temp dot next is none. Whenever it finds next pointer is none, that means when it will find once we reach the end node is having next pointer equal to none. That time what we need to do? The previous node next pointer we need to make it as a none. That for that instruction temp dot previous dot next equal to none. This is for last node deletion. And third use case, whenever the node is in the middle position. That means in our case, we have discussed the example, the third node deletion, right? This one. So whenever the node in a middle position, we have a else condition. That means we need to reach to that particular node position. And from that node, we need to perform the operations related to previous node and next node. That means temp dot previous dot next equal to temp dot next. We need to change the addresses, right? So for that reason, and temp dot next dot previous equal to temp dot previous. We have discussed already. Here, if you wanted to delete this node, this particular last node address 1000 needs to be placed here, and this particular node address 400 needs to be placed here. So for those operations, these are the codes. Okay, then return. So these are the three use cases, and print the list forward. In the display function also, we need to take reference, temp reference points to self head, and it has to traverse from beginning to end of the list, and we need to print each and every node data by using print data. First print the first node data and move to the next node, print the second node data likewise. So temp pointer moves to each and every node from beginning to end, and it prints all node elements. So we'll test this particular code. We have already the code is placed in that file. We'll try to find out. Yeah, this is the code file. Whatever the code we have discussed for delete function, this one. And how to create a linked list, how to append the data in the beginning, how to append the data at the end. Please see previous video, doubly linked list video. You can understand. In this session, we are discussing only delete function. So firstly, we are deleting 55. This one will run this code, save it and run. If you see the code instruction for a delete 55 means in this particular list, once we delete 55, we need to get 65, 75, 85. This is the main list. After deleting 55, remaining 3 elements. This is correct. Now we wanted to delete the last node data 85. We'll change the data here. So if we delete the 85, we should get again 3 elements. The first 3 elements 55, 65, 75. 65, 75. We'll save, run. Yeah, you can see 55, 65, 75. The last node data deleted. Now we'll check the last use case. That means we wanted to delete 75. This one. If we delete 75, we should get 3 elements 55, 65 followed by 85. So this is the output. We'll run. Yeah, you can see here 55, 65, 85. That means 75 got deleted. That's all for this session.